Good evening, sir.
Good evening, Siddharth ji. Yes, last day we have discussed some topics. Yes,
Yes, sir.
today also whole chemistry. Yes,
Yes, sir.
let me start. Introduce yourself. Briefly introduce yourself.
Sir, my name is Siddharth-CHEM and I live in Bhilwara and I have done my schooling from St. Senior Secondary School, Bhilwara. Then I went for my graduation to the Central University of Rajasthan and in year 2017 I qualified IIT-JEM exam and after that I got selected in Indian Institute of Science, Bangalore, and I did my post-graduation from there. And after my post-graduation, I qualified CSIR NET exam in year 2017 and 2021 and GATE exam in year 2020, 21 and 23. 21, 22 and 20. And recently I'm preparing for the government jobs and I'm appearing for this interview.
Yes, good. Yes, let me start. Move on
Yes.
chemistry. Yes.
Yes.
Last day we have discussed atomic structure, chemical bonding. Yes, two topics now.
Yes, sir. Yes, sir. Chemical bonding.
Chemical bonding and atomic structure.
Atomic structure and periodicity.
Yes.
Property.
Now is chemical kinetics. What is chemical kinetics? Can you
Sir,
explain?
chemical dynamics. Yes. Sir, chemical kinetics is a branch of chemistry which deals with the study of the study of rate of reaction. So in this field, we usually try to study the rate of the reaction. So by means of rate, we mean like for example, if we are having a reaction like A is going converted to the product. So what is the change in the concentration of this reactant with respect to the time? That is what we study in case of chemical kinetics.
Yes. What is rate law?
Sir, rate law is a law which has been given which defines the change in concentration of different reactants with respect to the products. For example, if I take an A, the small b of B gets converted to small c plus D of D, where A, B are the reactants, C and D are the products, and A, B, C, and D are their coefficients in which they are reacting, or we can say stoichiometry. So if we define the rate law, we define it as minus 1 by A dA by dt is equals to minus 1 by B dB by dt is equals to 1 by C dC by dt is equals to 1 by D of concentration of D by dt. So in this rate law, what we are looking, like we know, say if 1 mole of A will react with 1 mole of B, then it will get converted to 1 mole of C and 1 mole of D. So by representing in this rate law, we are saying that the change in concentration, if we assume 1 mole change, that the 1 mole change in concentration of A is equivalent with 1 mole change in concentration of B is equivalent to 1 mole change in concentration of C is equal to 1 mole change in concentration of D with respect to the time. And the signs which are shown here like negative are because the concentration of A and B are decreasing and concentration of C and D are increasing. So like this we can define the rate.
Yes, good. What is the difference between order and molecularity? Order of reaction and molecularity?
Sir, order is defined as the sum of the powers of the terms of the concentration in the rate law. For example, if we are having a reaction where A mole is getting converted to B mole. For assume, if we say, let's say stoichiometry is 2 for it, and it is a first order reaction, then we will write rate law is equals to K into concentration of A. Because it's a first order reaction, so here the concentration will have power 1. So when whatever the concentration have power or the sum of the powers, we call it as an order of reactions. Order is equal to 1. But since 2 mole of A are getting converted to 1 mole of B, so we can say the molecularity is equal to 2. Because molecularity is defined as how many moles of reactants are getting converted into the products. So we can define order and molecule.
Yes, good. What is first order reaction?
Sir, first order reaction is the reaction in which the rate is changed with respect to the concentration of reactants in first order. For example, if we define the rate is proportional to the concentration of the reactant to the power 1. This is the first order reaction when this happens. So we can write like this: the change in concentration of A minus dA by dt. If we remove the proportionality constant, we can write K to the power concentration. So this is the equation of rate for first.
What is pseudo order reaction?
The pseudo order reactions are those reactions which appears to be of higher order, but in actually they are of lower order or they are of different order. For example, if we take C2H5OCOCS, ethyl acetate plus water, and we decompose, we hydrolyze this, we get C2H5OH plus CS3COO. Now, if we look this as an elementary reaction, in case of elementary reaction, we are having molecularity equal to the order. Since molecularity is 2 here, so we assume that the order will be 2. Order equal to 2. But if we look in the actual experiment, we observe that since water is having an excess concentration, because excess is there, so the change in the molecules of the water with respect to the time will be negligible as compared to the change in the moles of the ethyl acetate. So if we look at the rate law, then from the experiment we find that it is only proportional to the concentration of ethyl acetate. So the reaction was appearing to be of second order, but in actually it was of first order. So these type of reactions are called as pseudo first order reactions or pseudo order reactions.
Yes, good. What is second order reaction?
The second order reactions are those reactions in which the rate is proportional to the power of to the second power of the concentration term. If a single molecule is reacting, or the sum of the powers of the concentration is equal to 2 if 2 molecules are reacting. For example, if we have A is getting converted to the product, then in case of second order reaction, rate will be proportional to the concentration of A to the square. But if we are having 2 molecules like A plus B getting converted to the product, then the rate is proportional to the concentration of A or concentration of B. In this case, there can be different cases also, like rate can be proportional to the concentration of A square or B0. It can be one case, or it is equal to A to the power 0, B square. It can also be one case. So ultimately, we look for the second order reaction, then the sum of the powers of the concentration terms will be always equal to 2. So this is for the second order reaction. This can be the cases. They are the second order reaction.
Yes, good. And what is third order reaction?
So third order reactions are those reactions in which the sum of the powers of the concentration terms will be always equal to 3. For example, if we are having, it can be one molecule reacting, it can be 2 molecules reacting, or it can be 3 molecules even reacting, or it can be multiple. But always the sum of the powers of the reactants in the rate law will be always equal to the 3.
Yes, good, good. What is half-life reactions?
The half-life is defined as the time taken for a reactant concentration to reduce to half of its initial value. For example, if a reactant A is getting converted into the product, and if it is having initial concentration C naught initial, and after a time T, we have C naught by 2 concentration of the reactant, then this time T is called as T half. So this is how we define the T half or half life.
Yes, half-life for zero order reaction. What is the formula?
Yes. So for zero order reaction, we are having A naught minus A equal to Q. This is the integrated form of rate equation. So if we have initial concentration A naught and final concentration is A at time T, then we define for T half implies A equal to A naught by 2 as from the condition. So implies we get T half equal to A naught by 2. This is the formula for T half or zero order.
Yes. What is the difference between reversible and irreversible reaction? Can we explain by graphical?
Okay, sir. So if we see a reversible reaction, then we write reaction A is getting converted to product, and there is one situation in which the reversible reactions are defined, like when A is getting converted into the product, the steps by which the A is getting converted into the products is by formation of equilibrium between the A and B at each and every step, and the reaction is so slow that it completes in an infinite time. But for the irreversible reaction, we can just simply say A is getting converted into a product. It can take in 1 step, 2 step, or some multiple step, but it will not go as slow as the reversible. So if we plot the rate of change in concentration of A with respect to the time, for a reversible reaction, we will have like this change in time. But for an irreversible, we can have any slope, like it can be linear also, it can be having some curve shape, and it can end also. So like this, we can have different plots for irreversible reactions. But for a reversible reaction, we will get change in concentration with respect to time. It will go till infinity, and it will not even complete even we are having T is equal to infinity. So we assume that it gets complete. It will go exponentially, it's very slow.
Yes, good. Next, we move. What is activation energy?
But when we are having a formation of products, for example, let's say N2 plus price of H2 goes to price of N3. So we know that the N2 and H2 molecules have some amount of initial energy. But from the collision theory or the activated complex theory, we know that for the formation of the products, there has to be change in energy for the molecules to react. And if we plot this energy, for example, if it is the initial energy with respect to the reaction product. If we represent that it is the N2 plus thrice H2 initial energy, then they have to go an energy change and raise their energy to this point, and after that the formation of the molecule will take place. So the amount of energy required for the reactants to react in the reaction. So we define this energy as the activation energy because this is the amount of energy that they need initially for these molecules to react with each other. So we define this as the minimum amount of energy that's required for the reaction.
What is the difference between exothermic and endothermic reactions?
Yes. In case of endothermic reaction, if a reaction is going from A to the product, then we need to supply heats to the molecules of A for the reaction to progress. But in case of exothermic reaction, if a reaction goes from the A to B, then we are having the heat is released. So we get delta H equals to negative and delta H equals to positive. So in this heat is supplied, then it is endothermic, and if heat is released in a reaction, then it is an exothermic. And or we can say, like if we draw in an energy diagram for exothermic energy, if a reactant is there of some energy and it is getting converted into the product. If the product is having higher energy than the reactant in the energy diagram, then the change in the energy will be positive because we need to supply the heat. But if we have a change in concentration of energy of the product, if products are having lower energy in the energy diagram, then we have having the energy is released from the product. So this is an exothermic reaction, and this is a case of endothermic. So like this also we can understand endothermic and exothermic. If we are required to supply the heat in case of energy diagram, or we are having energy of the products much higher than the energy of the reactants, then it is an endothermic, and if the energy of the products is lower than the energy of the reactants, then it is an exothermic.
Yes, good. What is the difference between steady state approximation and equilibrium approximation?
Yes. So, sir, in SSA, in case of steady state approximation, we define that the rate change for the formation of intermediate is equal to the zero. So what we mean by that, if we are having a molecule A and B, it is getting converted to intermediate I and then to the products. So whatever the rate change for the formation of this intermediate will be there, it will always be zero. So if we assume this in case of the steady state approximation, but in case of equilibrium approximation, we always assume that there is a equilibrium between the reactants and the products. So if A plus B goes to the product, then there will be an equilibrium between the both, and we can assume that the K equilibrium is equal to the concentration of P on concentration of A into concentration. So we can use the equilibrium concept for finding the terms. So,
yes, good. Michael, what is Michelson equations?
sir, Michaelis-Menten equation defines the enzyme kinetic behavior. Actually, what is mean by that? When a substrate S combines with the enzyme and forms the complex, that is enzyme substrate complex, then the rate change of this equation is defined with the help of Michaelis-Menten equation. But because the enzymes are having a specific nature towards the substrate, so the rate change is always not as sure, like it is a second order, so it will always not be a second order reaction. It is a complex reaction mechanism, and the Michaelis divide the equation by which we can predict the concentration change of the substrate and enzyme in the equation.
Yes, good. What is fast reactions?
The fast reactions are those reactions which are taking place in a minute second of time or even smaller second of time, because in these reactions there are a large number of molecules that reacts in a second. So ultimately we are getting a large, we can say define quantum yield, then we are getting a large quantum yield. Or if we define in terms of concentration, then the change in concentration will be very high with respect to the time. So those reactions which takes place rapidly, we define those reactions as the fast reactions.
Yes, good. Next, what is collision theory?
Sir, collision theory. Sir, it is a theory which predicts how the rate is changing with respect to the concentration of the reactant. And it defines that first thing, that the molecules are rigid. Whatever the molecules are reactive, they are rigid. Second thing, it defines that there is no attraction, no repulsion between the molecules. And third thing, it defines molecules are performing elastic collisions. That is, the energy and the momentum are conserved in those collisions. So based on these approximations, it defines, for example, if a reactant molecule A is reacting with the reactant molecule B and getting converted to the product. So for this reaction to proceed, the molecules A and B need to have an effective collision. And what is meant by effective collision is they need to have, first thing, proper energy, and second thing, proper orientation. So based on this effective collision only, the rate of a reaction is determined, because whatever the collision will be effective, it will lead to the product, and any other collision which will not be effective, it will never go to the product and it will again get converted into the reactants. So like this, it defines the rate of reaction.
Yes, good. What is Debye-Luckel limiting law and Debye-Luckel theory? What is
Yes.
the difference?
Sir, Debye-Luckel limiting law basically defines the coefficient of activity with respect to the change in the ionic strength of the solution. For example, if we are having a solute like A to the power gamma plus, okay, A to the power Z plus, and B to the power Z minus, and it gets dissolved as it will be okay. That will be like, okay, let's fix. If we have A to B, it's get dissociated as rise of A3 plus rise of B2. So we know that if A2B3 dissociates in the ions A3 plus and B2 plus, then they will have activity like 2 and 3. But if we look at the actual concentration or the activity, then it's different in the solutions. So the Debye-Luckel defined that the activity of plus is equals to gamma plus A of A3 plus. So this coefficient of activity which determines the actual activity, so it defined as a log of gamma plus minus is equals to minus 0.509 Z plus Z minus W dot. So by using this Debye-Luckel law or equation, we can easily determine the value of this coefficient of activity, and then we can determine the true activity which is there for the ions in the solution. So this is what is Debye-Luckel limiting.
That's good. What is colligative property and how many types of colligative properties?
Yes, sir, colligative properties are the properties which are shown by the solutes when they are dissolved in solutions. Like we are observing some type of properties, for example, temperature. So if we dissolve of a water is 100 degrees Celsius. And if we dissolve a solute in this water, then there will be change in this temperature. So the change in this temperature is due to the colligative property of this solute. So like this we can define the colligative properties. And the colligative properties are of 4 types. First one is relative lowering of vapor pressure. Second one is osmotic pressure. Third one is elevation in boiling point. Fourth one is depression in freezing point. So these are 4 types of colligative properties that are observed. And if we see in this, the changes which are we observing, whether it is in pressure or temperature, what we are seeing. So these are the physical parameters which are changing when we are dissolving a solute in case of solution. So if we can summarize that, the colligative properties are the properties which are shown by the solutes when they are dissolved in the solution by changing the physical parameters of the solution. Like this we can do colligative.
Yes, good. What is Raoult law?
So Raoult's law defines the vapor pressure of a solution when the different solutes are mixed in a solution. For example, if we are having a 2 solutes, A and B, which are getting mixed into a solution, so the final vapor pressure will be different from the vapor pressure of A and vapor pressure of B also. And if we assume that P0A is the pure vapor pressure of A and P0B is the pure vapor pressure of B in the solution, so the final vapor pressure P will be equal to XA P0A plus XB P0B. So it is equal to the sum of the mole fractions of the individual vapor pressures. So this is what Raoult's law defines, that how the vapor pressure of A and B is related to the final vapor pressure when A and B are mixed in a solution.
Yes, good. What is solution?
The solution we can define as solute plus solvent. Whereas particular amount of solute is dissolved in a solvent, we call it as solution. This is basic definition.
How many types of solutions?
Sorry, sir, I don't remember how many types.
Yes, solutions, types of
Okay,
solution.
okay. Means on basis of phase.
Yes,
Define. Okay, sir. So on basis of phase, there are 2 types of solution. First one is homogeneous solution, and second one is heterogeneous solution. So in case of homogeneous solution, the solute dissolves in solvent completely. But in case of heterogeneous, solute is partially dissolved. We can say, because in case of heterogeneous solution, we observe 2 different phases, and in case of homogeneous solution, we observe only one phase. Like this, we can do heterogeneous and homogeneous.
yes, good. What is the difference between ideal solution and non-ideal solution?
Sir, so, sir, in case of ideal solution, they obey Raoult's law,
Yes,
and they don't obey Raoult's. And in this case, we can, if we mix both the solution, then delta V mix will be equal to 0. Also, the enthalpy change in the solution will be equal to 0. But in this, delta V mix is not equal to 0, and even the delta H mix is not equal to 0. So this is basic difference between ideal and non-ideal.
Yes, good. Good answer. Well explained. Next is electrochemistry. What is electro?
Sorry. What's the question?
Electrochemistry. What is electrochemistry?
Okay. Electrochemistry is the branch of chemistry which deals with the change in the electrode potentials when a reaction is occurring between those electrodes and the solution. It can be one thing, or the electrochemistry is a branch of chemistry which deals with the change in the potentials when we are performing a reaction. So we can say electrochemistry as.
Yes. What is the difference between oxidation and reduction?
Oxidation means when there is increase in the oxidation state, and reduction means when there is decrease in oxidation state. For example, if we take copper and it loses 2 electrons and get converted to copper 2+, then we call that there is an increase in oxidation state, so it is oxidation. But if the similar copper 2+ takes 2 electrons and get converted to copper, then there is a lowering of oxidation state, so we call that as reduction. So like this we can define oxidation.
Yes, good, good. What is cell? What is cell?
Sir, you can define cell as, in case of cell, we are having 2 electrodes which are dipped in a solution of electrolyte. And electrolyte has both positive and negative ions, and the electrodes are connected to a battery where the one electrode is positively charged and other electrode is negatively charged. And in this system, there are continuous reactions happening which are called as redox reactions. That is, the oxidation and reduction are happening simultaneously. So, in whichever system we observe these oxidation, reduction, and this property, we define that system as the cell, or means chemical cell.
Yes, good. What is the difference between anode and cathode?
Okay, sir. Anode is defined as the electrode where oxidation takes place, and cathode is defined as electrode where reduction takes place.
Yes. What is the role of salt bridge in any cell?
Okay, sir, the role of salt bridge.
And function of salt bridge?
Yes, sir. First thing, to complete the circuit, it completes the circuit. Second thing, to maintain electron neutrality. In the reaction. So these are the two main functions which we observe for the salt bridge. First thing, it completes the circuit. Second thing, it maintains the electron neutrality of the solution by neutralizing the positive ions and the negative ions which are produced in the solution.
Yes, good. What is electropotential?
Sir, electrode potential is defined as the potential difference generated in the system when a reaction takes place in presence of electron. So, for example, if we are having a cell like this, and electrode is dissolved dipped in a solution, and it is connected to another system in which another electrode is dipped in the another solution. For example, let's say this is solution A, this is solution B, this is electrode A, and this is electrode B. So whatever the potential that is generated on this electrode is called its electrode potential, and the complete potential difference is called the EMF between the two. So electrode potential is just the potential that is developed on a single electrode when it is dipped in a solution and connected to the cell. So we define electrode potential as
EMF, yeah, you write down EMF. Yeah, what is EMF?
Sir, the potential difference that is generated between both these two cells.
Yes.
Both these two electrodes, whatever the potential difference that is generated, that will be called as EMF.
Yes, good. Why hydrogen is electron potential is 0?
Sir, it's not 0. We have assumed as a reference for the 0.
Yes.
Because finding the electrochemical series, we assume that whatever the potential have hydrogen is there, it is 0, and with respect to the hydrogen, we are defining the potential of other electrons. Yes. Because using the electrode potential, we need two electrodes. Single electrode, we can't measure the electrode potential. So for that, we take the reference of hydrogen.
Yes. What is the role of electrochemical series in electrochemistry?
The role of electrochemical series, it can be defined as, since the electrochemical series it is a series which is in the decreasing order of reduction potentials. Like whichever the elements which are having higher reduction potential, they are listed first and in the lowering of the reduction potential. So if we look at the electrochemical series, and if we look at an element like A, which is placed above the element B, then we can say the element A can easily reduce the element B in the electrochemical cell. So like this, using the electrochemical series, we can predict whether A will be more reactive or B will be more reactive using the electrochemical series.
What is Nernst equation?
The Nernst equation is an equation which defines the change in the EMF of an electrolytic cell. EMF of a cell with respect to the concentration of the reactants which are making the reaction in the electrolytic cell. For example, if we are having E cell, then it is equal to E naught cell minus RT on N log of Q. Q is the reaction coefficient here. For example, if a reaction happens between K plus and Cl minus, or let's assume copper 2 plus zinc goes to Zn2 plus.
Yes, good. Yes, today mock is over. Yes, you have. Yes, you well explained. Next day, we will discuss in left part in chemistry. Yes.
Okay, sir.
Today your mock is very well explained. Yes, good work. Keep going.
Anything which I can improve, especially during my mock, which I can improve.
Yes, improve day by day. Yeah. Today your explained is very well and confidential.
No, sir. What are the other things on which I should focus for my improvement? Means, is there anything else which I am giving, which I should do for improvement in my mock?
Improvement only teaching skill.